Dear students, in the previous class I have derived what is the formula for slope of a linear regression equation and y-intercept, and also I have explained the concept of least square method. In the formula of slope, then I have explained slope is nothing but covariance of the two variable, if it is the one independent variable, one dependent variable, simple linear regression, covariance divided by variance of independent variable. Then we also got another important result in the previous class, that if we want to draw a best line, that line has to pass through its average of x comma y value. That means that line has to pass through average value of x, that is x bar, and average value of y bar. In this class, what we are going to do, I have taken a problem. With the help of a small problem, I am going to find out the slope and y-intercept. Then I will explain the practical meaning of this y-intercept and the slope. This formula b1, nothing but the slope. If the line is, I am writing y equal to b0 plus b1 x, here the b1 is nothing but the slope. The slope is covariance divided by variance. We know that the formula for covariance is sigma of x minus x bar multiplied by y minus y bar divided by n minus 1 divided by the variance. The variance is sigma of x minus x bar whole square divided by n minus 1. Because in the numerator and the denominator n minus 1 is same, so when you cancel that, the remaining formula is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. There is another, if you are using calculator for examination purpose, this is a very useful notations convention. So by using, if you know sxx, the meaning of this sxx is sigma of x minus x bar whole square. The meaning of yy is a convention, sigma of y minus y bar whole square. If I write sxy, that is nothing but s of xy equal to sigma of x minus x bar multiplied by y minus y bar. The formula for slope is nothing but slope m equal to sxy divided by sxx. If I want to know error sum of square, I will explain what is the meaning of this error sum of square. Now you take this formula, what is error sum of square equal to syy minus sxy divided by sxx. Suppose why this formula is so useful, suppose if you know these three terms sxx, syy and sxy, you can find out the slope and you can find out the error sum of square. And this is convenient also later to find out the coefficient of determination. I will explain in the next lecture. So what is simple linear regression? Suppose that we have n pairs of observation, say x1 comma y1, x2 comma y2, like this xn comma y1. Previously we have seen the formula for slope. Now the formula for y-intercept b0 is equal to y bar minus b1 x bar. This also I have explained already how this formula has come. Here x1 is value of independent variable for the ith observation, yi is the value of dependent variable for ith observation, x bar is the mean value for independent variable, y bar is mean value for dependent variable. N, actually we are not using n here, n is the total number of observations to find out the mean value. So simple linear regression is, you see this is an x axis, this is your x axis, this is y axis. So whatever value which is here the dot, that is observed value, actual value, this line shows the critical value. So this line generally written as b0 plus b1x. The final objective any regression equation is to find out what is the slope of this line and y-intercept of the line. Because if you know slope and y-intercept, so this was our y-intercept. If you know y-intercept and slope, then you can construct the regression equation. The previous class I already explained, this is your error 1, this is error 2, this is error 3. So, the concept of least square method is the sum of the square of the error has to be minimized. So, that idea is taken care to find out the value of slope and y-intercept. We will take an example. Simple linear regression. Why it is called simple linear regression? So, only one independent variable is there. If there are more than one independent variable, that we will call it as multiple linear regression. We will take a small problem and I will explain how to construct a regression equation and how to use this formula of slope and y-intercept. An auto company periodically has a special week long sale. As a part of the advertising campaign, that company runs one or more television commercials during the weekend preceding the sale. Data from a sample of 5 previous sales are shown in the next slides. Actually, the company, before introducing a new product, they go for television advertisement. So, this problem says, is there any effect of television advertisement on the sales of the car? So, the data says number of TV ads 1, the number of cars sold 14. When the number of TV ad is 3, number of cars sold is 24. Number of TV ads is 2, number of cars sold is 18. Number of TV ad is 1, number of cars sold is 17. Number of TV ads is 3, number of cars sold is 27. In this, the dependent variable is number of cars sold. Generally, we will call it as y is a dependent variable. The independent variable is x, that is nothing but number of TV ads. So, we have to know effect of this number of ads on the number of cars sold. Generally, what is the perception? When you the frequency of ad is more, there will be more sales. The first task is to slope of the estimated regression equation. So, what we have to do? First we have to find out x bar and y bar. Okay. Then for each value of x, you have to find out x minus x bar, and for each value of y, you have to find out y minus y bar. Then you have to multiply that, then you have to sum that multiplication, that leads to 20. Then sigma of x minus x bar, you have to square that, then you have to sum it, that is 4. So, the slope is 5. The y-intercept for the estimated regression equation is B0 is y bar minus B1 x bar. Already we know B1. So, you take B1 value here, y bar we know it is 20, x bar is 2, this is 10. So, the estimated regression equation is 10 plus 5x. You have to very careful, this is estimated regression equation, it is not y. The value of y is the estimated value, it is not the actual value, it is nothing but the mean value. So, y equal to 10 plus 5x. So, how to interpret this? When the value of x is increasing 1 unit, the y will be increased by 5 units, right. So, keeping other things constant, when x is increased by 1 unit, the sales will increase by 5 times, not the 15 times, because you should not write 5 into 1 equal to 50, because we are seeing rate of increment of x and rate of increment of y. Yeah, this shows that this one y equal to 5x plus 10, right. So, here the 10 is a y-intercept. When you extend this, this is your y-intercept, okay. 5 is the slope. So, suppose if the TV number of TV advertisement is a 5, say now we have taken up to 4, suppose it is a 5, you can put here 5, 25 plus 10, 35. This is way there is a trend line, that is a regression line. So, this one we will do with the help of Python. Import numpy as np, import matplotlib.pyplot as plt, import cbone as sns, import pandas as pd, import matplotlib as mpl, import statmodels.formula.api as sm from sklearn, see that this one sklearn, that is the library for running linear regression. sklearn dot linear underscore model import linear regression from scipy import stats. First I have entered this value in Excel. I am going to save that file name object called tb1, tb1 equal to pd.read underscore excel. This was the path where I have stored my Excel file. First task is you have to plot the scatter plot. So, scatter plot is we have to see generally we can go for correlation. Here also we can, this scatter plot will say a rough idea about what will happen when the value of x increases and how it is affect the y. So, what is happening, you see that even there are some point when the number of TV ads is increasing, the car sales also increasing. So, TBL dot plot TV ads comma car sold style equal to O, PLT dot Y label car sold, PLT dot title sales in several UK regions, that is a heading, PLT dot show, that will show the this graph. Next one T, I am going to save that TV ads in variable called T, T equal to TB1 TV ads in quote, C equal to car sold. Here the car sold is dependent variable, TV ads is independent variable. Import stats models dot API as S. So, T equal to S dot add underscore constant of T, because we need to have the T. So, model 1 I am saving as model 1 equal to SM dot OLS, OLS means ordinary least square method, C comma T. What is the C here? C is your dependent variable, T is independent variable. So, result 1 equal to model 1 dot fit parenthesis. So, print result 1 dot summary parenthesis square that. This was the output of your linear regression equations. So, if you look at this, most importantly you see that the coefficient. So, how to write this one? Y equal to, so the constant is 10 plus 5 TV ads. There are many terms there here, say model is OLS, method is least square when it was conducted, number of observation is 5, number of residuals, residual is nothing but our error. Here the R square is 0.877, I will explain the meaning of 877 the next class. Then the adjusted R square, this value of adjusted R square interpreted for a multiple regression equation. I will explain what is this F statistic next class. Then there are many fitness indexes there. So, there is a standard error, this is a T value, I will explain T value. And one more thing is here, you look at the probability value. Suppose alpha equal to 5%, the probability is less than 0.05, then we can say it is a significant. I will explain this also in the next class. So, this is the output of our regression equation. We will take another problem on regression analysis. The problem is the data in the file, I have a file called hardness.xls, provides measurement on the hardness and tensile strength for 35 specimen of die cast aluminum. It is believed that hardness, that is measured in the Rockwell E unit, can be used to predict tensile strength measured in thousands of pounds per square inch. So, what are the things has to do is construct a scatter plot, assuming a linear relationship, use the least square method to find the regression coefficient for B0 and B1, interpret the meaning of slope B1 in this problem, predict the mean tensile strength for the die cast aluminum that has hardness of 30 Rockwell E units. So, there is a tensile strength is given, hardness is given. For this data set we are going to construct a regression equation. So, we will switch to Python, I will tell you how to do this one. So, for this we have to import pandas as PD, import numpy as NP, from sklearn import linear underscore model, import statsmodel.api as SM, from sklearn.metrics import mean underscore squared error. First I will load the data in the object called data. So run it. Import pandas as PD, import numpy as NP, from sklearn import linear underscore model, import statsmodel.api as SM, from sklearn.metrics import mean underscore squared error. So the file I have stored in an object called data. So the data shows this is the tensile strength and hardness. What we are going to do, there are 35 data set that we are going to split into two categories, one is for training, another one is for testing. For that purpose, from sklearn.model underscore selection import train underscore test underscore split. So x equal to data, so x value is going to be hardness dot values dot reshape. So the reshape command is used to convert one dimensional array into two dimensional array. Then y equal to data, that is a tensile strength. So x is independent variable, y is dependent variable. The next one is x underscore train comma x underscore test comma y underscore train comma y underscore test equal to train underscore test underscore split x comma y comma test underscore size equal to 20%. So this 20%, what is the meaning is, say 20% of the data will be kept for testing our model. Remaining 80% of the data will be used for building our regression model. So random underscore stat equal to, you can give any number so that when you repeat this program again you may get the same answer. Because the 20% of the data is randomly chosen out of 35 data set. So if you use this shape command, now you can see, I will run this one. So you are getting 28 comma 1. So 28 data set is for training, 7 data set is for testing. Okay. So we can see the length also, length command also you can see that 28 for training, 7 is for testing. This is a trained data set. Now we will go for constructing the regression model. From sklearn.linear underscore model import linear regression. So regression equal to linear regression. When you run this, we will run this model. So now we will see what is the y-intercept. So the y-intercept is 7.045. So the regression coefficient is 1.9974. So now we will predict for the test data set, we will predict what is the y value. So this is your predicted y value when giving x data set as an input. Now we will find out what is the mean squared error. The mean squared error is 35. So if the error is smaller, that model is good model. The next one is the fitness of this regression model is nothing but 0.53 by taking x underscore data set as an independent variable and y underscore data set as a dependent variable. The next when you say for training data set, it is 0.45. I will explain the meaning of this score data. The meaning of score is, the meaning of score is nothing but your R square. This R square is nothing but coefficient of determination. So the coefficient of determination is your SSR divided by SST. So SSR is regression sum of square, SST is total sum of square. In our problem, the R square is, see that the reg underscore x underscore test underscore y test is, the R square is say 53%. So what is meaning of this 53 is, the 53% of the variability of y is explained with the help of this x independent variable. For the training data set, it is 0.45, that is the 45% of the variability of y is explained with the help of independent variable x. This mean squared error is nothing but SSE divided by n minus 2 degrees of freedom, that is the mean squared of error. If it is the lesser value, the model is good fit, otherwise it is not good. Now we will see the another concept in the regression model, that is called machine learning. In machine learning, this is one category of supervised learning. The machine learning techniques are classified into two categories. One is supervised learning method and another one is unsupervised learning method. So, the regression is example for supervised learning, because in advance we are labeling what is independent variable and what is dependent variable. If it is unsupervised learning, so we cannot label in advance that what is going to be dependent and what is independent variable. So, in the supervised learning is nothing but the regression analysis, but in the context of machine learning we will call it as supervised learning. In statistics we will call it as simple regression. Dear students, in the previous class I have derived the formula for y-intercept and the slope. Then I have taken one sample problem. With the help of sample problem I have explained how to use that formulas and also solved with the help of Python. I have taken another problem also. In that problem the data set is divided into two parts. One part is for building the data set, that is using training data set. The another part of the data set, that is for test data set. So, the test data set was used for validating the model which we have constructed. Thank you very much.